Alright, here is a typical word problem. A ball is thrown upward with an initial velocity of 64 feet per second from a height of 8 feet. The height of the ball in h in feet and t seconds is given by the equation h equals negative 16t squared plus 64t plus 8. And we're asked to find, for instance, you want to find out the height of the ball after 3/4 of a second. Well, obviously, if you're looking at the graph, we can't really designate where 3/4 of a second is. We can roughly guess it's somewhere around there, but it's tough to find it on this graph. So this is where we have to use our table function in the calculator. But then we go to our table function. We might have to set up the table function by hitting second window or second table set and change the window or the option to either ask, or we can go by 0.25 seconds. And when we look in the table set, we're looking at 0.75 seconds. And when we get this 0.75 seconds, we see that the height of the ball at that point is at 47 feet. So the answer for when it equals 3/4 of a second, you gotta use the table function to find that out. Now, a lot of times they'll ask us to find out when the height of the ball, say, for instance, is 2 times when the height of the ball is at 17 feet. Well, at 17 feet, again, it's tough to use the table function because we can't find 17 for the y value. So what we need to do is we need to plug in a second line into our graphing calculator under y2, and we're going to just simply graph a horizontal line at 17 feet. And when we graph that on the calculator, you'll have a line that comes through here, a horizontal line that goes through. And now what we can use is we can use our intersect key. So we hit second trace, and we want to find the intersection button here, or intersection there, and the intersection there. And so by using the second trace to get the calc menu, option number 5, which is our intersection method, then you hit enter, 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 and it will give you a value for that location there as well as a value for that location there. So that's how you find out when the height of a ball at 2 different times, when it reaches 2 different times. If you're interested in finding out the maximum height of the ball, what you're really looking for is right up here, the vertex, which is also known as the vertex. So by finding the vertex, you essentially find the maximum height of the ball. And remember our vertex formula for finding out the x-coordinate, it's negative b over 2a. So you substitute here's your a, here's your b, and here is your c. So you can plug in the values and solve and get the x point, and then once you get the x point, you back substitute in to get the y point. And in this case, the y point is what you're looking for the height. So your y, of course, your y coordinate of the vertex corresponds to the height of the ball, while your x coordinate of the vertex corresponds to how many seconds it takes to reach that maximum point. So once you find the vertex of this formula, x and y, you essentially have found the times and seconds as well as the height, maximum height of this ball thrown up in the air. So that's what you want to do for that. Find the number of seconds it takes for a ball to reach maximum height. You've done that. And then finally, how long does it take to hit the ground? What you're looking for is when it hits the ground here. So another thing you can do is you can graph another y2 line, take away the 17 and plug in y0. And what that does is graph a line right on the x-axis. And again, to find out that value, then you can use the second trace button and find out that intersection point right there. So that's how you can find how long it takes for the ball to hit the ground. So